Hello, my name is Jacob Jewett. Welcome to my first video in a series of videos where I will be covering the exam objectives for the current CompTIA Network Plus exam series N10-007. In this video, I will be covering the objective 1.5 of the exam, where CompTIA states that you will need to be able to compare and contrast the differences of network types. During this video series, I will be using this book as a guide to how I order the release of objectives I cover and when. It should be noted that the book does go into some topics not directly referenced by the CompTIA exam objectives. While I may cover some of these topics, I will do my best to adhere to the topics directly referenced by CompTIA. If you have access to this book, it will be a great tool along with these videos to get you on your path to achieving certification. You can pause this video now or check down in the description of this video for information on where you can access or buy this book. Additionally, if certification is not something that you are currently seeking, the videos in this series should be helpful in helping you understand networks in general. Another resource that you should strongly consider referencing when preparing to take the CompTIA Net Plus exam is the Certification Exam Objectives published by CompTIA. Again, check the description of this video for a link that will take you to their download page. So let's get to it. Objective 1.5 states that you need to be able to compare and contrast the characteristics of network types. So now we're going to talk about LANs and wireless LANs. So in a LAN, the important thing to know about LANs is, and we're talking about local area networks, typically local area networks are private networks. You will not find a public local area network unless a business has decided to allow external customers to connect to their network. Typically that's a one-off or a group of customers or contractors. But a typical LAN will look kind of like this, and what's important to understand about a LAN is it's typically confined to one building or a house. And I'll show that example here shortly. But what you see here is an example of a client-server network, and it's set up as a LAN. So you have your firewall connected to the internet. So internet and cloud are essentially the same exact thing. The reason why the internet has been called the cloud is because in IT, in network diagrams, we've always depicted the internet as a cloud, and some savvy marketer caught wind of that and decided that that's a new marketing term. But any IT professional that's been in the industry for a while will tell you that that's how we've always described the internet, is we've always shown it as a cloud. What you have in a typical LAN is you have a building that is connected to the internet. Okay, so you have a building that's connected to the internet through a firewall to a router. The router then goes to switches in a server client or a client server kind of setup. You'll see that there's servers up here where everything's like centrally stored, okay, or services are provided centrally. Instead of every user on the network having a printer connected to their workstation, you'll typically have, like, if this was one floor or one office area, you would have one printer assigned there, and all these computers would print to that one printer. And that would be handled by a print server. So in this one, in my example, I have the print server here. Mail server, typically mail servers are now hosted in the cloud through like Office or O365 or Office 365 with Microsoft, or even an offering by Google. They have their suite, their Google suite that's in the cloud, and actually does mail services. On-premise mail servers are going the way of the Dido, or whatever you want to call it. So you have a directory server and typically a file server. So in a client server kind of setup, you will actually have these systems down here. When someone tries to log on here, they're not actually logging onto this machine. This machine is communicating through the network to the directory server, checking to make sure that that user is authentic. If that user is authentic, the password matches, everything matches, it will then go back down and authorize that user to use this computer. So in a client server setup, all the computers are usually part of what they call active domain or active directory domain structure. And so all their permissions are actually centrally stored, and you can't log on to them. So no one machine holds its own authentication set. Now, that's a client server setup. This is a LAN. This is typically what you'll run into. So another type of LAN is a home LAN. And in this one, we'll also describe a wireless LAN. And so here's a typical home for you in this day and age. You'll have your wireless router that either your ISP will give to you, and hopefully you're not really using that as your main connection, but you'll have that router, and then you'll have it connected, or your cable modem, and then you'll have that connected to, let's say, a Linksys or a Netgear wireless router. So typically your wireless router acts as your firewall and everything like that if you have it set up and updated. But here's not only an example of a home LAN, okay, but it's an example of a wireless LAN as well. Okay, so the difference between a LAN, a pure definition of a LAN, and a wireless LAN is one is physically connected via a cable and one is not. So one communicates over the airwaves versus being connected with a cable. Okay, whether you're looking at a corporate network that exists in one building or one that exists in your home, a LAN is down to that. It can be on one floor of a building, it can be a whole building, it can be your house. So typically a LAN doesn't stretch beyond one building or one floor. One more thing to note here is previously when I showed the corporate network, I described this as being a client-server environment where the servers up here provided services to the workstations down here. And I also described the fact that this computer here did not control its own authentication. When a user actually gets onto this computer or logs onto this computer, their authentication or their authority to log on to this computer is actually verified by the Active Directory server. Okay, everything in a client-server setup is controlled by the centrally managed servers in this environment. In this design here, all these computers here do not connect to a central location. You could almost argue that one of these computers would connect via like the cloud to Office 365 or Azure or something like that. But in this environment, when it's in a home, it is considered to be part of what's called a home group, if you enable that in Windows, or a work group. Let's say, for example, this isn't a home, but a small office. Let's say a real estate office with maybe 5 realtors that belong to that company. Some are wireless, they bring in their laptops, and the main secretary's computer is actually connected, hardwired to the network. Since there is no central server for this environment, this would be considered in a office to be a work group. Okay, and in a work group, each computer supports its own authentication, meaning that the authentication on this, or the authentication list, also known as the ACL, Access Control List, or in a work group, it's also known as a SAM, a Security Access Management. Okay, in this environment, this computer's access rights is different from this computer's access rights. Okay, so if you had user A want to get on user B's computer, and this is computer B, they would have to have rights assigned to them on this computer to allow them to connect, since there is no central server. Okay, since there is no central server, this is what's called a peer-to-peer network, meaning this computer can get files from this computer and vice versa based upon who has rights to connect to which computer. This can get very complicated in the long run, because what will happen eventually, let's just imagine that you're a technician for this environment and you get called in one day and all these computers are set in place and they hire another realtor, or let's say they let go of a realtor because they are not producing, are not selling houses, and they hire a new realtor. What you would have to do in that instance for that realtor, the new realtor, to get access to these computers and the old realtor to be removed from these computers, you would actually have to physically sit down at each one of these computers, remove the user account for the old realtor, and then add, at the same time, hopefully, a new user account for the new realtor. Okay, so it comes down to this. In a work group or a home group kind of setting, its general rule of thumb is to keep these peer-to-peer environments down to about 10 nodes or 10 hosts. Okay, and a host or a node is the same thing. Basically, a host is any device on the network that can send and receive data. So if it's sending data from a switch to another host on the network, being a workstation, it is considered a host. Another confusing term is node, and all node stands for is any device that is in the network or on an endpoint of a network. So technically, everything you see here and everything you see here is an individual node. The firewall would be considered a node, the router a node, the switch a node, the workstation a node, and the server a node. Okay, and again, interchangeably, they're also called hosts. And typically a host is anything on the network that can send and receive data by definition. So about the only thing that is not really technically considered a host in this diagram is the printer, because the printer is an output device and not typically an input device. Okay, so again, this is a client-server network, and this network here would be considered peer-to-peer because there is no central storage or central location where things are authenticated. The next one that we'll have is a CAN, or a Campus Area Network. They've also changed this to a corporate area network, as not to confuse people. But the way I'm trying to lay this out is from what they actually test you for, and you're going to get a lot of questions on. So what we've done is we've gone from one building or one LAN to multiple buildings, okay, and multiple LANs. Now, the important thing to understand about a campus area network or a corporate area network is you need to understand that these will exist in one plot of land, okay? So if you see here, I got north-south street and west-east street, and it's on a corner of a street, right? So I assume that, you know, if there's another street up here, maybe this company is taking a block and they have multiple buildings in that block. This would be considered a campus or a corporate network, okay? And it can span multiple buildings within one geographical location, okay? So if you put your finger on a map and your finger ended up at a cross street, that would be one geographical location, and that's where a CAN would exist, okay? So you may see in my diagrams, I have the internet connected to a firewall to a router outside of a building. Just assume that these buildings are, or these firewalls and routers are actually within a building. And in this diagram here, you'll see that the buildings are actually connected via fiber connection from one building to the next. Okay, that would be some like an underground conduit kind of setup. They could also be connected via wireless from building to building, point to point. That would probably be the worst idea because wireless is not exactly that fast unless you're going with like 802.11 AC, and then that's got limitations on it. So fiber is usually a lot faster and much more reliable, especially if you're working with a big campus. So if you've ever been on a college campus or your high school campus is big, typically that's what we're talking about, is one geographical location, multiple buildings connected together, create a CAN. Be very vigilant on the different sizes of networks because CompTIA will test you on these, and they are very particular. So if you think, oh, well, I have multiple buildings in a location, there's multiple LANs, so that's a WAN, that's a wide area network, you would be incorrect, okay? And the reason why I have to mention this is in the industry, a lot of technicians will get lazy and call a network that they have where they have multiple locations within the same city or same location, they'll call those WANs and they would be incorrect, okay? The correct term for it would, if it's in one geographic location, being on like a corner of a street, it would be CAN, okay? And then our next one would be, let me switch back. Our next one would be MEMS, or Metropolitan Area Network. A Metropolitan Area Network can be a single building, another campus, another single building, another campus, another single building, okay? For example, let's say that this one is your headquarters, so you have a campus of like 5 buildings, okay? So you would have multiple LANs in this area, and each one of the buildings in your corporate office or corporate campus, each building would be considered a LAN. The 5 buildings together would be considered a CAN, or a corporate area network, or campus area network. And then when you have multiple locations within a geographical location, either it being a city, in this case the city of Los Angeles, or the county, you could say the county of Los Angeles, which is kind of bigger than this. So you'll see that this goes from Los Angeles to Anaheim, to Santa Ana, all these Torrance, all of them refer to themselves as their separate cities. If you go to Torrance and say that you're in LA, they'll get mad at you. If you go to Anaheim and say that you're in Los Angeles, they'll kick you out. Just know that if it's in a geographic location where you have either a city or a county, and you have multiple locations in that county. For example, where I live, they have Kern Regional Healthcare, and Kern Regional Healthcare has multiple locations just in Kern County. They would be considered a metropolitan area network, and of course, it would be a private network. Okay, and again, with the firewall and the router, assume that those are in like one of the buildings, and they're just connected. Now, these connections between these locations could be lines that they've purchased and ran themselves, or dedicated trunks that they've purchased from communications companies, or they could be just going through the web through like dedicated site-to-site VPNs or something like that, or a MPX or not MPX, MPLS, something like that. If they're going through like a MPLS, which is a dedicated line, this would be another way. So even though we're not depicting the internet here, these would still be considered private network because only the corporation has access to it. It may be going through the internet or cloud, but since each one of these locations are directly communicating with each other through the cloud, it's still considered a private network, and in this case it would be called a metropolitan area network. So going from city, now we finally go to our WAN. So we're going to talk about WANs now, and WANs are wide area networks. Okay, wide area networks span vast areas. And you'll notice in this depiction of it, the cloud I actually took out. You don't see the cloud here, and the reason why you do not see the cloud here is, number one, if you got communication going like this across the world for a company or a client or anything like that, more than likely they're going through the cloud to make this happen. This could be different data center locations for them if they're like a ISP provider themselves. But the idea is these links between each other are dedicated links. What you see here is what I'm going to talk in a previous, not in previous, but I'm going to talk in a future video. These links are redundant links, and this would be considered what they call mesh topology, which I'll talk about later. But a wide area network can be as small as the United States. For example, if we decided that we were going to have a location in California and then have a location in, I guess that building looks like it could be like in Tennessee or something like that, or even in Minnesota. You know, the fact that it goes over a vast distance, okay, the fact that it goes over a vast distance, that would be now defined as a WAN, or a wide area network. So it can go over a vast distance, or it can go it can go on the same continent or go multiple continents. Basically, just get the idea that a WAN is a very large network, and so you know, just understand the sizes because they will again quiz you on it as far as the exam is concerned. Next, we're going to talk about PANs. PANs is not like Peter Pan or something like that. This is called a personal area network. And very simply, it's the kind of the smallest network that really exists. And typically, it's defined as you providing your own personal connection. So let's imagine that you've got your cell phone here, and this cell phone you've set up as being a wireless access point or a personal wireless access point area. Okay, you could be sharing with your laptop, your camera. Let's say you have a GoPro, and it's connected Bluetooth to your phone. That's a short distance travel. Typical Bluetooth will only go about 30 feet reliably. A tablet could be connected either directly to the internet itself. Your watch, let's say you have like an Apple Watch or a Android equivalent, like a Samsung watch that communicates with your phone, or wireless headphones that communicate with your phone, or even your laptop. Things that communicate in your personal area are considered a PAN, and this is like the smallest network that you'll refer to. And finally, we talk about SANs, and SANs is a storage area network. And you may notice this diagram from earlier. This was the building that I showed you before. And you have your LAN, or your local area network, that exists within that building. Okay, and then we said that this is a client-server setup. So you have your clients down here, and you have your servers up here. Well, in this day and age, most servers are virtualized. And we'll talk about that in a future video, get deeper into that. But whether it's a physical box, meaning you can touch it, or it's a virtualized box that exists on a physical box that you have at the location, the virtual or physical box will typically have a back end to it for a storage network. So you'll have either dedicated appliances from, let's say, Pure Storage, or Nimble, or something like that, or even HP. HP does some server racks, and we'll talk about that in future videos. But you'll have a storage area network where you have a bunch of storage on the back end. These can be quite huge. The company I currently work for, our back end storage is quite large. It's not quite a petabyte, but it's got a lot of, we have a lot of storage, and that storage is redundant. So it's connected together via fiber, or a what they call fiber link. And typically what we do is, for redundancy, this storage will be connected to 2 different switches or more, and you'll see redundant connections, and typically that will be repeated on the server side. There will be redundant connections as well. The idea behind this is, if this switch died, or you had to do maintenance on this switch, you would never lose your connection to your storage network. And it's just a built-in kind of redundancy kind of setup. But what you need to understand about SAN stands for Storage Area Network, and it's typically a dedicated network for storage. If you notice here, these switches are not connected to either the LAN or the public network. They are connected in the back end. They have typically their own backbone, and they will not share a network connection with the rest of the network. Now, you may say, oh, well, this is expensive, and you would be right. But companies that use SANs, or storage area networks, typically need to make sure that all communication that happens on their storage area network is that of storage-related communication, and not Joe Blow on computer number 3 here watching YouTube or Netflix, congesting the rest of the network traffic. If let's say, for example, we took all of our storage area network storage and put it over here on the main segment of the network, that would become a problem, because if all these guys are watching YouTube, watching my beautiful videos, or H3 or something like that, or watching Netflix or anything like that, the problem is they will congest the network, and it'll basically starve these services of getting access to the storage. So that's, again, in like data centers and big server farms, they'll typically have a SAN setup versus having the storage on each individual system. The neat thing about SANs is you could have a file server completely die, like the hardware or even the virtual machine, and you haven't lost any of your information. Also, the nice part of SAN storage networks or storage area networks is typically the backup solutions that you have for these. You can do things like snapshotting and stuff like that, right? So one of the things I didn't cover before that I want to sort of cover here, and it's covered in the chapter 1 of the guidebook that we're going through, but is not part of the objectives, but you need to know the difference. They talk about intranet, and extranet. Okay, so easily put, internet, whenever you refer to the internet, okay, when you refer to the internet, you're basically saying that your user here is going to the internet or the cloud for a service. Okay, so that would be considered internet. If you go to msn.com or you go to YouTube or anything like that, you are using an internet or cloud service. Okay, the fact that it's on the internet is why it's called an internet communication. We also have something called intranet. Intranet is a service that's typically provided by your servers in your network. Let's say, for example, you have a SharePoint website hosted on your file server, okay? And that's typically where people get this term confused. But basically, an intranet service is anything that's provided locally to the LAN or your MAN, WAN, anything that's private network provided. Okay, so if you have a service that's provided by this server and it's provided to your clients, whether this again is a LAN, WAN, MAN, CAN, as long as it's within your private organization, that would be considered an intranet service. An extranet service is if, let's say you had a user in the internet, let's say he's, let's go back here. I didn't create a slide for this. So let's say you have a user that's normally based in Los Angeles, okay? Or that building looks more like it's in Arizona or Nevada. So let's say they're in that location and they have to travel to another location. Let's say, for example, they have to travel to Brazil. So they're in Brazil, and obviously you don't have a location in Brazil, or you have it somewhere in Peru, right? So you don't have a location in Brazil, but they need to still connect to the office. Or it could be a contractor, or it could be, let's say, an employee that's traveled to Brazil for vacation. Okay, he's in Rio de Janeiro having a great time. Well, he still needs to be able to connect to applications and services that are provided by your corporation. Let's say he uses like an ERP system or a inventory control system, and he has to check inventory for a client. Okay, obviously, if that's not hosted in the cloud, if it's not hosted in the internet, and it's hosted in your intranet, he needs to be able to get access to it. So typically what you'll do is you'll set up like a VPN connection. Again, that will be covered in a future video, but you'll set up a connection that allows him to communicate, let's say with the Peru facility because it's close by, or if there's no facility in Peru, he connects to the home office in Nevada, okay? He or she will be able to access the application that's hosted by your company And that VPN connection, or that connection that you provide him or her outside of your company's private network, would be considered an extranet. So that's pretty much it for this video covering Objective 1.5 of the CompTIA Network Plus exam. There are 2 other sections of this particular objective, which I will cover in future videos that will be coming out shortly. If you have any additional questions, please feel free to leave a comment in the comment section of this video. If you would rather get your question answered live, please feel free to join my live streams, which I do every Sunday night at 8 p.m. Pacific time and every Wednesday night at 8 p.m. Pacific time. On those live streams, I leave it open for questions. I also have an option for Patreon. If you got something out of these videos and would like to support me, I do have a Patreon page, and it is listed in the description of this video. And I do have tiers on there to get you top of the list of getting your questions answered, and I have a bunch of plans for that in the future. All funds raised through that will go to the production of these videos. I do realize that this video is long, and it's longer than I wanted to make it. However, a lot of the information I felt important enough to include in this video. In future videos, I will shorten them down some. I plan on future videos being about 10 to 15 minutes. All right, so if you, again, like this video, please give me a thumbs up. If you didn't like it, thumbs down. If you have suggestions, please, again, include them in the comment section of this video. And I, again, am always open to suggestions, and we'll go from there. Thank you very much for joining me. I look forward to seeing you again in a future video. So long for now.